Assalamu alaikum, my dear students. I hope all of you are fine and doing well. The topic we are going to discuss today it is the properties of the alkynes. So let's see that what are the main properties of the alkynes. When we have a simple compounds, it just contain two types of properties. The first one type we have its physical properties, and the second type we have its chemical properties. So when we talk about the physical properties, it just simple belongs to its physical state at room temperature, what will be its melting point, its boiling point, and what will be the density of the substance. So we will all just simple learn it is in the physical properties. On the other hand, when we have a look on the chemical properties, so here we just have the reaction of the substance or the compounds with the other substances. What is its reaction rate? It is faster or it is slower? What are the main products it just produces when it reacts with the simple compounds? So the first one we have the simple physical properties of the alkynes. Basically, alkynes are non-polar compounds. As they are non-polar compounds, it means they will be insoluble in water. So the second property is they are insoluble in water. Third one we have they are soluble in non-polar organic solvents. Now, what are the non-polar organic solvents? We have a lot of compounds. First one we have benzene, we have acetone, we have gasoline, we have oil. All are the simple non-polar organic solvents. So just alkynes soluble in these compounds. Then they are less denser than water. If their density is less than water, it's mean when we just put them in the water, for example, this is the water, and they are less denser than water. So when we just put into them, they will float over the surface of the water. The reason is that the water is more denser, so it will be at the lower part, and the alkynes as less denser they will be on the top of the substance. Then alkynes have low melting points and the boiling points because they are non-polar, and their melting points and boiling points increases as their number of carbon increases. It means when we increase the number of carbon atoms, their melting and boiling points both just increases because their chain length increases. At the end, the terminal alkynes in which the two carbon atoms have triple bond. They are more acidic than the other hydrocarbons. Terminal hydroalkynes means if we have a long chain of carbon atoms like this, and the two terminal carbon atoms have triple bond as compared to this compound in which the two central carbon atoms have the triple bond. So they will be more acidic in nature. On the other hand, when we have just simple series of the alkynes, they are mainly colorless gas. The first member, they are mainly colorless gas with the some garlic odor, and they are also lighter than air. They are lighter than air. So these are the simple physical properties of the alkynes. Then we have their chemical properties, that how do they chemically react with the different substances. So alkynes are basically reactive compounds. These compounds are known as reactive compounds. Now the question arises why they are known as the reactive compounds. The simple reason is that because of the presence of the triple bond. As triple bond is present in between two carbon atoms, so that's why the alkynes are basically more reactive. As a triple bond just consists of the one bond, which is the sigma bond, it is strong. On the other hand, these two bonds are known as the pi bond, and these bonds are weak and they are easy to break. So that's why when alkynes just react with the other substances, these two weak bonds just break down and they just give the type of reaction which is known as the addition reaction easily. And the addition reaction of the alkynes also resembles with the reactions of the alkenes, as the alkenes also have double bond, between two carbon atoms and one bond is weaker. So their reactions are some having a resemblance with the alkenes. So first chemical reaction is the addition of the halogens. When we have a simple alkyne, which is known as the acetylene, this is its simple name, and its IUPAC name we have ethine. It reacts with the halogen atoms, so these halogen atoms will get attached on the triple bond of the carbon atoms and it changes into the tetra halide, which is the product of the result of this reaction. So this is the simple one reaction. We can also add the remaining halogens, which may be bromine, as well as we can also add here the chlorine. So when bromine is just added into the acetylene, here what is going to be happen, the red brown color of the bromine water just start has here the bromine is having red brown color. When we add it in the acetylene or ethine, its brown color just disappear and it forms a colorless tetrabromoethane. So we can also use this as a test for the checking of the presence of the alkynes. So this is also the main test for the identification of the alkynes. Then we have the second reaction of the alkynes with KMnO4 in the presence of water. This is mainly known as the oxidation with potassium permanganate. That how we can use basically when ethine is oxidized with potassium permanganate and we use four hydroxyl groups. Or here we have two water molecules, so they will produce the hydroxyl group. The main product we have four hydroxyl groups just attached to the two carbon atoms which were having the triple bond along with the production of the manganese dioxide and potassium hydroxide. So in this process there is a production of the an intermediate. So let's have that intermediate. We have the four hydroxyl groups along with the two carbon atoms. When we remove two water molecules, there is a production of the glyoxyl, double bond O, and this is the glyoxyl. And after its oxidation again by the addition of the oxygen and the presence of KMnO4, this is its we have the production of the oxalic acid. So this is oxalic acid. We can also write the oxalic acid as COOH and hold twice. We can also write it as COOH and bond COOH. So this is the simple production of the oxalic acid. When the ethyne just react or undergoes oxidation with KMnO4, they produces the oxalic acid, which is the main product. So I hope you guys understand about the topic, and if you have any queries you may ask me about that. And the next topic we will discuss it is the uses of the alkynes, that where we can use the alkynes in our daily life or in the industries or for the production of the different chemicals. For that time you guys keep learning and have a good day.